Homework 2.1, page 93. Okay, number 18, you see this graph right here. First of all, I want to know where it's increasing. So it's increasing, it's getting larger here. So that's from 4 through infinity. Okay, it's decreasing in this area right here. So from negative infinity up to -1. It's constant across this line right here, so from -1 to 4. The domain, okay, are my x values. So this graph keeps going, so all these x's are included, and these are included, and this keeps going, so all my x's are included over here. So you can write it as all real numbers, or from negative infinity or positive infinity. And the range, these will keep going up, so all these y's are included, but these y's are not included. So we'll say from 3 and above, so from 3 to infinity. Okay, number 20, same thing there. So it's increasing, it's never increasing here, it's always decreasing the whole time. So it's decreasing from negative infinity through positive infinity. We'll say decreases from negative infinity to positive infinity. The constant, no constant. The domain goes all these x's and all those x's, all real numbers. And the range, this will keep going up, even though it's really not going up by a lot every time. It is still going to go up, and this is going to still go down. So that also is going to be all real numbers. Okay, 22, it is increasing, okay, decrease, constant, increase. So increasing from 3 through infinity. Oh, actually I messed up there, it's an open circle. So it'd be like this, okay. It is decreasing here. So from negative infinity all the way up through -3. Open circle. It's constant from here to here. So from -3 to +3, and that +3 there is including the 3. The domain, okay, all my x's are included all the way up, oh, not -3 though, right? And then all these x's are included, and this is included up there at 3, and then it's included, right? So we can say it's going to be all real numbers, but x does not equal -3. Okay. Then for the y's, okay, so we don't have a y here at 1, okay, but we do have them for greater than 1, and we don't have anything less than 1, so we're going to say greater than 1. Okay, not or equal to because it's open. Okay. Number 24. Okay, 24, you had to look at the graph. So if you look at the graph of this, you can put it into Desmos. Negative x to the third looks something like this. Okay, so from negative infinity to positive infinity, it is decreasing. Okay, 26, x to the 4th. I want to make sure I get the graph right, 1 second. Yep, okay. So the graph of this goes down like this, kind of does something there, and then comes up like this. A lot of x to the 4th will have 3 turns into it, but we'll talk about that another time. So we're thinking about it from negative infinity up until 0. Okay, so from negative infinity to 0, it is decreasing. Okay, 28. We have negative absolute value of x. Okay, so that negative flips it upside down, so it's going to open like this. And we're going to look at it from 0 to infinity. So from 0 to infinity, just looking at this part of it, that is decreasing. Number 30, square root goes like this. The negative of it opens it up like this instead. And we're looking at it from 0 to infinity. So from 0 to infinity, it's decreasing. These have all been decreased. They're not always going to be decreasing, but anyway. 32. Okay. Y equals x squared minus 2x. Okay, this graph looks like this. And it's 32. It says we're looking at it from 1 to infinity. So this is at 1 to infinity. So we're looking at this part of it. So that part of it is increasing. Okay, 34. Okay, so this graph looks like this. And we're looking at it from negative infinity to negative 1. So we're looking at this part of it. That part of it is decreasing. Okay, 36, we're looking to see whether they're x-axis, y-axis, or origin symmetry. So on the x-axis, that is a good reflection, so A is yes on the x-axis. B, it is not a reflection across the y-axis. And C, no, it is not a 180-degree rotation or across the origin. Okay, 38. Okay, so across the x-axis is not true. Across the y-axis is not true. Across the origin, if you think about this being rotated 180 degrees around the origin, that is a yes. Number 40. Okay, if you think about a point being, if this is reflected across your x-axis, that's a yes. Across your y-axis, that's a yes. And if I rotate that 180 degrees, that'll still be the same shape. So yes, yes, and yes. Okay, 42. Across the x-axis, that has that that's the y-axis. X-axis, that is not true. Across the y-axis is a yes. And if I rotate that around, it would not look the same, so no. For number 44, they're asking us if it is odd or even. Okay, so remember odd is around the origin, and even is around the y. Okay, so remember, try and remember those together. Okay, so if you look at this, is it odd? Is it reflected around the origin? No. Oh, it says complete the right half, so it is. Okay, so here's the graph here. So if we want it to be odd, so part A, odd, to be reflected around the origin, it would then have to be like that. So that gets rotated around there. Okay? And if we want to take the whole thing, that part, and reflect it across the y-axis, here's my y, it would look like that. With number 46, we want to complete it so that it's odd. If you remember from our notes, we said an odd has to be around the origin. And we said that if there is some point AB, then the point negative A, negative B would also have to be on there. Okay? So if you're filling out this table, okay, so if negative 5, 13 is on there, then the negative of each of those also have to be on there. So 5 and negative 13 would have to be on there. Same thing here. If 3, negative 1, the opposite of both would be negative 3, positive 1. Okay. Negative 2 would be 2, and the opposite would be 5. And 0 would just be at 0, 0. Okay, with number 48, we had said that if it's even, even is across the y axis. So if you think about reflection, if I have a point A, B, okay, then across here would be, across the y, if this is A, negative A, B would also have to be on there. And if it's across the origin, if I have A, B, okay, reflected across there would be the point negative A, negative B. Okay, so we're thinking about that here. So number 48, if I have this point here, if it would be even, let's do odds first. AB would be negative A, negative B, right? So negative this and negative this. Oh, nope, not true. So the negative of this would be 3, but the negative of that is not negative 16 there, so that's not true. Okay, so it's not odd. Let's take even. Okay, so I have AB, and then the negative of A and B, so that works. AB, the negative A and B, that's good. And the same thing there with this one as well. So 48, we would say that that is an even function. Okay, number 50. Okay, so we'll go with the two opposites first for the odd. So opposite of A and opposite there is good. Opposite there and opposite there is good. Opposite there and opposite there is good. So number 50 is an odd function. 52. Okay, we look for the opposites. So negative 3 and 3. Nope, that's not reflected across the y-axis there. Okay, let's check the origin. So the negative and nope, that doesn't work there either for that one. So that's neither. Okay, with number 54, we have to decide if it's odd or even from the equation. So we had this in our notes. We find f of negative x in both of them. And if it equals the original function, we know that it's even. And if it equals the opposite of the original function, then it's odd. Okay? So if our f of x is equal to this, our f of negative x would equal this. Okay? Now, if you take a negative number and raise it to the 6th power, negative times a 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 negative is a positive, basically even versus odd. So it's a positive times negative 2 would be negative 2x to the 6th. A negative squared also makes it positive, so it would be negative 8x squared. Notice this is equal to the original. Okay, when it's equal to the original, that is an even function. Okay, 56. We have negative x to the 5th plus 2x to the 3rd minus 3x. Okay, so if I do f of negative x, I plug that in here. So negative x to the 5th plus 2 times negative x to the 3rd minus 3 times negative x. Okay, now I work this out. Negative to the 5th power is a negative, times this negative makes that positive x to the 5th. Negative to the 3rd power is negative, times positive 2 is negative 2x to the 3rd, and a negative times a negative is a positive 3x. Okay, notice it's not equal to our original, but it is equal to the opposite of the f of x. So if I put a negative of the original, that's equal to that. Therefore, it is an even function. 58. We have 8. Okay, so if I find the opposite of it, it's still equal to 8, right? So it is equal to our original. It is not equal to the negative of our original. So therefore, it is an even function. Number 60. There's our original function. So if I find the opposite of it, okay, to the 3rd power, odd power, it's going to still be negative, and negative makes that a positive. So notice once again, that is equal to the opposite of our f of x. When I distribute that negative through, it's negative x to the 3rd plus 4x, which is like that. which makes that an odd function. 62. Our original function is the square root of x squared plus 1. So f of negative x would be this. Squaring it gives you x squared. So you can see that is equal to our original one, which makes it even. 64. We have 4x minus 1 over x. So if I find f of negative x, it'd be 4 times negative x minus 1 over negative x. So this makes that a negative 4x, and two negatives equal a positive. You can see that that is just the opposite of this. And when it is in the opposite of it, that makes that an odd function. 66 is really the same idea as these other ones. We're defining whether it's odd or even, but it's asking us to take it a step farther and saying, is it reflected across the y or is it reflected across the origin if it's odd or even? So, if we find f of negative x, okay, this makes that a negative x to the fifth. That's negative times that, which makes it a positive 2x to the third. Notice it is opposite of what that is. When it's opposite of that, that means it's an odd function. And if it's an odd function, it's reflected across the origin. Okay, 68. Okay, so define f of negative x here. Okay, so negative squared makes that still a positive, so 0.75x squared. Oop, that's absolute value. Absolute value of a negative makes it a positive. So you notice it is the same exact thing as what we had in the beginning. When it's the same exact thing, we say it is an even function. And if it's an even function, that means it's reflected across the y-axis. Number 70. Okay, find that f of negative x. Okay, so that makes that a positive x to the fourth, makes that a positive 5x and a positive 2. Okay, so you notice it is not equal to this because that's negative. It's also not equal to the negative of this. So therefore it is neither not odd nor even. In the last problem, okay, we find that negative again. So negative to the third power gives it still negative x to the third, and negative negative makes that a positive 3x. Once again, it's opposite of what we have there, okay? And if it's opposite of what we have, that is an odd function. If it's an odd function, it's across the origin. Okay, that is the homework.